All right, so we've done a lot of modeling with Algeblocks and using Algeblocks to make sense of different algebraic functions and expressions. So now let's see if we can try our tools out on some more real-world-like problems or more contextualized problems. So we're going to work together on 1, 3, and 5. And I'll leave 2 and 4 for you to think about, to work through. If you have trouble with those, let me know, and I'll record the videos for those as well. So let's look at number 1. One leg of a triangle is 7 centimeters less than the length of the other leg. The length of the hypotenuse is 13 centimeters. Find the length of the legs. So here's a situation where we need to make sense of the information that we're given and maybe some information that we have from before as well. So they give us a picture of a triangle that they want us to be looking at. So, and they're saying if we just read and try to make sense of everything that they're talking about and try to put that information on the floor, on the picture, we'll see what we can do and to solve this problem. So one leg of the right triangle, so it's a right triangle, is 7 centimeters less than the other leg. So what are legs? Now the triangles have, right triangles have a hypotenuse, which is given to us, and it has legs, right? So triangles do have legs, and those are the two sides that are not the hypotenuse. So we know that the right triangle, the one leg is 7 centimeters less than another leg. So let's say this is 7 centimeters less than this leg. Okay, what else do we know? The length of the hypotenuse is 13 centimeters. And then we need to find the actual lengths of the legs. So we can do this by trying. What if one leg is 1 centimeter and the other leg is 8, right? We could try that out. It's not going to give us 13 for hypotenuse. How about 2 and 9? How about 3 and 10? So we can do all of that. We can try things out. But we can also see if maybe we can use a little bit more mathematics to help us with this problem. So let's say that the vertical leg is 7 centimeters less than the horizontal leg. Now, we don't know how much, what either of those legs are. So often when we don't know, we use a letter for unknown. So let's use X. And we could have used X for the horizontal leg or the vertical leg. But one of those we can set up as an unknown, the one that we're going to find. So if that's X, if the horizontal leg is X, then what would the vertical leg be? Well, we know that it's 7 centimeters less than the other leg. So would it make sense that it's X minus 7? Now, it's quite possible that kids would say, no, I want this to be X. And if that one is 7 centimeters less, then this would be X plus 7. Right? It's all about the definition of the variable that you take. And there are lots of different, well, in this case, 2 possibilities of what you can define as your unknown. So which one are we going to go with? It's up to you. This is the one I have written down right now, so I'll go with this one. So if now I have a a right triangle with X and X plus 7 and 13, what else do I know from the past, from other mathematics that I know to be true? So one thing we know is that we can relate all of the side lengths of a triangle using the Pythagorean theorem. Well, what is Pythagorean theorem? A squared plus b squared equals c squared. Now remember, any triangle has legs and a hypotenuse. So these two are our legs, and this is our hypotenuse. Right, so let's see if we can figure this out. So we have x squared plus x plus 7 squared equals 13 squared. So I wonder if we can figure this out using Algeblocks. Well, what is x by x? X squared is just x squared. Now, if we're looking at x plus 7 squared, it's going to be the x, 3, 4, 5, 6, 7, and then an x, 1, 2, 3, 4, 5, 6, 7. So this is going to be the rectangle. It's actually a square. And if we actually draw it out, make sense of this, right, of this particular multiplication, and that one is there. So I see a whole bunch of ones, right? In fact, 7 by 7 ones. Mm-hmm. I also see a bunch of both of these x's. So that's 7x and another 7x. And I see 1x squared. So let's multiply this out. We get x squared plus 14x plus 49 equals, and what's 13 squared? 169. Well, we can simplify all of this, right? We know that we have the x squared, somewhere in here we have the x squared from before, from the first leg. So in total we have 2x squared plus 14x plus 49 equals 169. Now we need to figure out how to solve this equation by maybe coming up with an associated function. Now the associated function, wouldn't it be nice if we had 0 on one side? If we could find the value of that function as 0. So 2x squared plus 14x minus, right, 120 equals 0. Is that possible to calculate? Now I'm going to delete this one. Didn't have enough room. Let's get back. So how do we do that? How do we figure out what that factored form is? What do you think? How do you think we could figure this out? Find x. Now you notice that all of the numbers, all of the coefficient in this function are even. So we could split this into half and half. And if the total is 0, then each half should be 0 too, right? Or we can view it this way. 2 of the whole of the 2x squared, of the x squared, the 7x, and the minus 60, and we have 2 layers of that. So we have a total of 2 of the x squared, and 2 layers of the 7x, which is 14x, and 2 layers of negative 60, which is negative 120, equal to 0. So if 2 times something equals 0, then that something inside must equal to 0 as well. So we could, although we could factor the ugly function as well, the more complex function as well, we could also factor this one. Because if 1 is 0, then this smaller one has to be 0 as well. So let's see if we can make this with our Algeblocks. So we have x squared and 7x and minus 60. So somewhere in here is going to have to be minus 60. And the 7x is going to be sitting here. So 60 could be 10 by 6 or 5 by 12 or 3 times 20 or 15 times 4 or 2 times 30. 2, 3, 4, 5, 6. Yep. Okay. So it could be these rectangles, the minus 60 could be a 10 by 6 rectangle or 5 by 12. But notice that we're going to have to use 0 pairs. There's going to have to be some kind of new x's being added, but that are same on top and bottom. But there's a 7x here, so there's a difference between the 2 dimensions that are 7. So if you look at our factors, potential factors, the 5 by 12 is actually a really good candidate because the difference here is 7. So if we look at 5 by 12, so 1, 2, 3, 4, 5. Okay, imagine that that's evenly split by 12. Okay, then we would have to add a 5x here and a 5x there, right? And that would give us a rectangle. So we could factor this into x plus 12 and x minus 5. So then what we would have is either the x plus 12 equals 0, the x minus 5 equals 0. So either x equals minus 12 or x equals 5. Great. So let's go look and see what those answers would mean for our triangle. Remember this triangle here? Let's go see what that would mean. So let me put in x equals minus 12. So if this is minus 12, then this is minus 5. Wait, what? The legs of a triangle are negative? Well, although our mathematics was turned out pretty well, this is really a theoretical value that doesn't make sense in our actual problem. And that's perfectly fine, that happens. So let's get rid of those. So it's not actually going to be interpretable in our real situation. But x plus 5, if this is 5 and this is 12, then we certainly could have this this triangle with 12 and 5 are the legs and 13 is the hypotenuse, because 12 squared is 144 plus 25 is 169, which is 13 squared. So that is going to be our answer for the length of one of the legs. So the legs are 5 centimeters and 12 centimeters. And that will be our answer. So look at the big picture of this. The big picture is we drew what we needed to, what we knew from the explanation and from the problem set. We brought in some information that we knew in general from geometry, in this case. We combined, or we applied the number 2, the information that we knew, to our situation. Then we used the mathematics that we know to solve this problem. So we looked at the associated function, we factored it, we used the Algeblocks, and we came up with 2 answers. And then we went back to our information, to our number 1, and we said, do any of these answers make sense? And we found the one that does make sense, whereas the other one did not. So do you see those steps? So 1 was making sense and drawing the problem. 2 was trying to bring in other things that we know from outside. 3 was combining the 2. 4 was using some kind of method, a mathematical method, to solve or to work out the problem. To the 5, the final answer of that model. And we checked those answers against the problem that was originally set in number 1 to come up with 6. That is the legs, the actual potential realistic answers to our problem. Okay. Now, number 2 is very similar to that. Let us go into question 3. And what I would like to do is copy this. And let's put it into, oops. There we go. Number 3. The frame of a picture is 10 inches by 8 inches outside and is of uniform width. What is the width of the frame if 24 inches squared of picture shows? Okay. So let's see. So first we drew out our picture, our situation. So let's draw that out right now. So 1. We drew out the situation. Here's our frame, and we know that it is 10 by 8 inches. And it's of uniform width. So this, it's of uniform width. So this, and this, and this, and this are all uniform. And we know that the width of the, what is the width of the frame? We need to know what that width is. If 24 inches squared are showing in the area. Okay, so this is a challenging problem, right? We have a couple of things that we don't know. And we have two different kinds of dimensions. Okay, so let's see what else we might be able to know to be able to bring, to use this function, this particular, to use mathematics to solve this problem. So right, and for number 2, we tried to look back to the mathematics that we knew in order to be able to help us solve. Well, one thing we know is the area of a rectangle, right? And we know that that area is length times base, or length times height, or width times base, whichever, it's multiplying the two dimensions. So what's really interesting is that we know the outside area, right? And we know the inside area, but we don't know the width of the frame, the actual wood. So how do we combine those two things, right? That's part 3 for us. How do we combine those two things in order to have some kind of an equation that we can solve? Well, let's see. So first, we have this unknown that is x. Because it's uniform, it's going to be x for all of these widths. So what do we know? Well, we know that the total area is 8 by 10 inches squared. So 80 inches squared, right? We know that. Does that help us? Well, maybe. What else do we know? We know that the inside area is 24 inches squared. So we know that the border area, right, is 80 minus 24 is 56 inches squared. All right, we know a lot of stuff. We don't know that we'll use all of it, but we do know a lot of stuff. Is there another way that we can calculate this border area? Well, we have a bunch of rectangles here. Right, we have this rectangle, and this rectangle, and this rectangle, and this rectangle. In fact, we have 4 rectangles. What are the horizontal rectangles? What are the dimensions of those? Do you see that they're 10 wide by x high? Right, that's the area of border. Plus another one of those, right? Plus, well, what are the areas of the vertical rectangles? Well, they're x wide, but how tall are they? Do you see that everything, the whole height is 8, but we're cutting off an x here and cutting off an x here. So it's going to be 8 minus 2x. Right, so it's x by 8 minus 2x, plus another one of those. Okay, and that equals 56 square inches. So let's see if we can figure this out a little bit. And because this is promising, this is an equation. It's really ugly, but it's an equation. Maybe we can simplify that. If we have 10x and 10x, that's actually 20x. And this x by 8 minus 2x we can model. If we have x by 8, 1, 2, 3, 4, 5, 6, 7, 8, minus 2x, this rectangle, right? So we have minus negative 2x squared, and then positive 8x. And then we'll have another one of those. And that equals to 56. So let's see if we can simplify this a little bit more. We got negative 4x squared, right? Because we're doing this twice, same thing twice. And then we had the 20x from before and 2 of the 8x's. So plus 36x equals 56. Okay. So let's see if we can find an associated function for this. Right, because now we've combined what we knew from the problem from number 1 plus what we knew from before, the area, number 2. We combined all that to come up with an equation to solve. So what was the fourth step here? The associated equation and trying to solve it. Okay, so let's see if we can find the associated equation. So our f of x is going to be minus 4x squared plus 36x minus 56 equals 0, right? We could use that. Now, I wonder if I could simplify any of this. Now, if I have 4x squared, so I have 4 different x squareds, and then I have 36 x's, and that's in groups of 4 too, right? And 56, that's in groups of 4 as well. So what if I say, okay, use the distributive property backwards and say 4, there's 4 of the negative x squareds plus 4 of the 9x's, right? 4 groups of 9x minus, okay, 4 14s equals 0. Now that seems a little bit easier. So if that equals 0, then the inside has to be equal to 0 because 4 times something is equal to 0. That something must be 0. Let's see if we can factor that. Negative x squared, 9x. So we would have the 9x somewhere in here. And then negative 14. So somewhere in here, we would have our negative 14. Okay, so let's lay out our 9x's. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9x's. And negative 14. So how are we going to do the 14? Could be 14, could be a 2 by 7. And that's it, 7 by 2 and 1 by 14. So let's see if we can come up with if we can draw a 2 by 7 in here. So if we have 2 by 7, we would come up here. Okay. We have some extra two rods in here, and we have 2 missing rods in here. Oh, but they're both positive. So couldn't we move these 2 from the negative to the positive? You see it? There we go. Moving from the negative to the positive. So we actually have the 7x here, negative 7x, and positive 7x, pardon me, and 2x here. So that's a total of 9x. All right, so how do we then write this out? Negative x plus 7, negative x, and x minus 2 equals 0. So x is either 7 or x is 2. Okay. All right, so let's take this back. 7 inches or 2 inches. So, right, we are now at the point where at number 5 we had our answers. So now for number 6, for final step, we need to take these answers and see if they work back in our situation. So let's take x equals 7. If we have a 10 by 8 and an even width inside, and if this width is 7 and 7, do you see that we have a problem? Right? There's no way that the width could be 7, 2 widths of 7 and 7, and those would be inside a 10-inch wide frame. So that's not going to work. So let's see if we can come up with something else. Let's try the other number. Let's try 2. 2 and 2. Okay, and 2 and 2. So then the inside would be 10 minus the 4, which is 6. 6 by 4. And is that 24 square inches? It is indeed. So this x equals 2 is our answer. So the width of the frame is 2 inches. All right. And notice we had exactly the same steps. So in the first problem, we had drew the situation. And in 2, we figured out if there's anything else that was relevant that we knew already. So same thing here. We drew the situation in 1, and in 2, we brought in something else that we knew about the situation. In 3, we combined the two things, the two bits of information, into one equation. So in number 3, we did the same thing here. We tried to play with all the information that we knew, total area, inside area, border area, all of these things, to come up with an equation that was true for our situation. In 4, we came up with a associated area and solved it, right, using Algeblocks, using whatever tools we had. In 5, we ended up coming up with 2 solutions. And finally, in 6, we took them back to our original picture, our original situation, and realized that one of those solutions is absurd. It's not realistic for. We ended up checking the second solution, which did in fact work, which was in fact our second solution. Okay, and the last question in this section, where we're going to try and put together what we know from the situation, what we make sense of, as well as some information that we know from outside. And we're going to try and solve the problem, use our mathematical strategies to solve the problem. So in problem 5, we have International Space Agency. They landed on some planet out of the solar system, and they're testing what happens on that planet to the baseball ball that's thrown directly up from their probe. So we have that to demonstrate the crushing weight of gravity on this planet, the lander's camera is aimed at a probe ground level ejection port. At the ground level ejection port. So from the ground, we're going to shoot a ball up, directly up. And it's going to go up, up and up and up and up and up and up. And then it's going to turn around, up, and it's going to go down, 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 down. Okay. So it's going to shoot the speed, the velocity at start is going to be 147 feet per second up. The force due to gravity on this planet, so force due to gravity is 98 feet per second squared. Assuming that there's no wind and nothing else is in the way, how long will it take? So time to smack is what we want to know. Okay, so we've drawn this, and you may be looking at this saying, I really have no idea. With all this information, we have the force, we have the velocity, we have acceleration here, and time. So we really need, although we were able to complete our step 1, for step 2, we really need to go outside and do a little bit of research. Well, the problem itself does provide us with some information here. So it provides us with the fact that, let's bring this over here, with the fact that that there's a function h of t equals minus 1/2 gt squared plus v initial t plus h initial. Now, do you remember that this would be from any physics class that you may have taken? And if you didn't take it, let's just look at this function as something that's given and figure out what's going on with each of the variables. So the initial velocity, okay, and then the h0 is the initial height. And the coefficient for the leading term includes the force of gravity. So this g is the force of gravity. Okay, and on Earth is 32 feet per second squared, or 9.8 meters per second squared. and t is time. Okay, so that was our information from outside. So in our third step, what we need to do is we need to combine the step number one, where we have all this information about the situation, and the information from number two, to combine them and figure out if we can generate some information about this particular situation. Okay, so let's see if for number three we can combine some of that information. So the velocity at the start is 147 feet per second. So this is our initial velocity that we can fill in. We also know that force due to gravity is 98 feet squared per second. So 98 feet per second squared, pardon me. Now, do we know the height at the start? Well, it did say that it started at 0. It was ground level ejection, so 0 feet. Now, when it smacks down, back down on this planet, it's also going to be at 0 feet at 0 feet height. So what can we figure out now, and how can we combine that equation with the information that's given to us into a single function? So we have 0, that's our height at time t, negative a half, 98, t squared, plus 147t plus 0. So I've substituted the information I knew from 1 into the equation that I knew from 2, the function that I knew from 2. So let's simplify this a little bit. So 0 equals negative 49t squared plus 147t. Okay. Now factoring this, you are welcome to do on the Algeblocks, but we also know that we can factor out a t. The first term is a t squared, so one of the sides will be t, and the second term is a t, so one of the sides will be t. So we can divide out the t, so to get negative 49t plus 147, 0. Okay, so either t is equal to 0 or this is equal to 0. So let's see, t is equal to 0, or negative 49t plus 147 equals to 0. And we can solve this equation. The linear equation, t equals negative 147 divided by negative 49, and I think that's 3. All right, because 3 times 50 is 150, and that's 3 less. All right, so that's 3, and that's time, so seconds. 0 seconds and 3 seconds. That is, so this is our fourth step. We found our fifth step. This is 0 seconds and 3 seconds is our mathematical theoretical answers. Let's see if they make sense in our actual problem. So for number 6, the 0 seconds, at 0, our height, at time equals 0, our height is going to be 0. Is that the question that we want to answer? Does that have to do with the question that we want to answer? Whereas at time equals 0, that part is actually at the start, right? The ball was, or whatever, yeah, the baseball was at 0 when it was shot up from the probe. So yeah, that makes sense. But that's at the start. That's not the question that we were being asked. At 3 seconds, that's at the end, when the baseball comes smashing down back to the surface of the planet. So that is what we're looking for. That's the answer we're looking for. So it will smack down after 3 seconds. So notice that all of this whole solution strategy has an argument, has a path of figuring things out. It's not memorizing how you do this. It's not a memorization. It's not a drill situation. It's a situation of making sense of what's happening, of trying to bring back what you know from outside, of this particular situation, some theory perhaps, and of combining those two, and then of using some mathematical techniques to solve, and then reinterpreting it back, because sometimes the mathematics gives you some of the answers that are not meaningful, that don't actually make sense. So that's the big picture of how we're going to be looking at applications to these problems.